Okay, this is where we stopped on the last video. We're talking about left and right sided limits, and the key to remember here again is that the limit goes to the same thing, same number from both sides. The limit from the left and the limit from the right have to go to the same number. So we discussed right before I stopped the video here that is a plus sign, right? That stands for from the right. So think about it in terms of like a graph, right? Everything over here is positive and everything over here is negative. So from the right, or the positive side, and if there's a minus there, we'll get to that, that's from the left. So anyway, this is saying as x approaches 2 from the right, right, what does it go to? All right, remember, x values get plugged in, your answer is what you get out. Your answer is like your y, right? So you plug in an x value, the answer you get is like a y value. So the answer you get is not only just a y value, it's your height. So what this is actually saying is, as x approaches 2 from the right, basically what it's asking is, as x approaches 2 from the right, what is the height? Where is it at? Where's the height? As x approaches 2 from the right, the height of this is approaching 1, right? Looks to me like it's approaching 1. So from the right side, right, from the right side, as x approaches 2, as our x goes to 2, right, it's looking to me like it's approaching 1. That's the height right there. Okay? See what it goes to on the y-axis. We are looking for the height, right? We're looking for the answer. You plug in an x, you get a y out. We are looking for the answer. I'm looking for the height. Okay? From the left, again, like I just said, from the left is negative, right? Because picture that like a negative side. This is the negative side of your x-axis, so it's coming from the left. So from the left, x is approaching 2 from the left. What's the height? Well, it looks to me like the height is -1, right? Looks like the height of that is only at -1. So taking a look at this, as x approaches 2 from the left, because it's negative, where is the height at? Where is our answer at? Looks to me like it's approaching -1. We see what it goes to again on the y-axis. Look at the height. The height as from the left, it looks like it's approaching -1. In order for a limit to exist, it must go to the same spot on both sides. It has to. Well, we just said the limit from the left and the limit from the right have to equal each other. If we want this limit to exist, right? If we want the limit, L standing for limit, if we want the number, that limit to exist, it must go to the same thing on the left and the same thing on the right. It has to go to the same number. Well, look at this problem. All right? The limit doesn't exist because the right and the left sides do not match up, right? You just told me from this picture it looks like it's approaching -1 from this side, and right here it looks like it's approaching 1 from that side. That's not the same answer. From the right it goes to 1. From the left it goes to -1. It has to go to the same point, right? From the left, -1. From the right, 1. It's not going to the same spot. And that's why the limit in this problem does not exist, right? This limit, let me get back to the actual thing here. This limit does not exist. And we just abbreviate that with this. Does not exist, D&E. You can just write that down. The limit of this problem, our picture, our graph of f of x, does not exist because the right and the left sides did not match up. They do not go to the same point. They are not at the same height. Okay? Here's example 4 now. Alright, taking a look at this. Find the limit. Okay, so we're trying to find the limit for example 4. This is g of x. Even though it jumps, the whole thing is g of x. Alright? So again, maybe you want to take a minute and just kind of draw the pic Write it down. It's just a rough sketch. Try to get as exact as you can. It's not a big deal. All right, the key is, where does it look like this is approaching at 2? Where does it look like this is approaching at 2? Remember, x value, we're looking at where it approaches on the x. It's approaching 2. It's approaching 2, but the answer we're looking for is the y-axis, up and down. Find the limit as x approaches 3. All right, as the limit as x approaches 3 exists. Does it? Right? Now, as x approaches 3, I'm doing this on purpose. Most people sit there and go, ooh, there's 3. Oh, it's jumping. That's wrong. That's not the case. As your x value approaches 3, as the x value right here approaches 3, well, if I go up, the number 3 is right here. So, picture that right there. From the left, right, it's going to, I don't know what that number would be, right, but whatever it is, from the left and from the right, it's going to the same exact spot, right? From the left, it's going here to this point, whatever that is. Let's just say it's 4. And from the right, it's also going to 4. It's going to the same spot, because remember, it's as x approaches 3, what is the height? And they are both going to the same height at that point. Just look at the graph. There are no holes at 3, right? I don't see any holes there like we see here. I don't see any holes. Remember, when x is 3, not y. We're looking for when x is 3, yep, from the right, yep, and from the left. All right, it's approaching, sorry, from the right and from the left, sorry. But notice that we do have an issue. We do have an issue here at 2. We do have an issue. As x approaches 2, it looks like from the left it's 1. And as x approaches 2 from the right, it looks like it's 3. So to me, I would say from the look of this picture, it looks to me like the limit exists at 3, but it does not exist at 2. And some people wonder, what about that point in between there? What's that? All right, this is where it gets not necessarily difficult, but just deep for you to understand. The limit is about the height of your function. Where's the height? The height from the right is 3. The height from the left is 1, right? It's where it is at, 1. The height from the right is 3. As I see here, the limit doesn't exist. But this point is very crucial. This point is crucial because if I asked you, when x equals 2, what's our answer? At x equals 2, our actual number answer is 2. There is a point there at 2. When x equals 2, y equals 2. As the limit approaches 2, that approaches 1 from the left and 3 from the right. So the limit does not exist because we have a jump. But that specific point does exist. There's a difference between getting an answer and getting a limit. And we'll have to go into that in a little bit as well. So the limit at 2, all right, from the right, all right, it looks like it's going to 3. From the left, it looks like it's going to 1. From the right, I made it positive. From the right, looks like it's going to 3. We just said this again. From the left, right, from the left, it looks like it's going to 1. So the limit, right, the limit as x approaches 2 does not exist. Okay, the limit does not exist. That point again, so we can describe it. What about that point? That point does not matter when we're finding limits because we only care about what happens as it approaches 2, not at 2. Right? What happens as it approaches 2 on the x? As it approaches 2 on the x. We don't care what happens exactly at the number 2. At exactly number 2, the answer would be 2. All right? Example 5. Find the limit of h of x. All right, same deal. find the limit. Find the limit from the right. So, from the right, as x approaches 5, it looks to me like the height would be 3, right? The height is 3. Next up, the limit from the left limit. So, as it approaches 5 from the left, it looks to me like it's also approaching 3, right? Again, I know we have a little hole there. It's a jump. I know we have a hole. But we want to know what happens as it approaches the number 5. As x approaches 5, it looks like it's going to 3. As x approaches the number 5, it looks like it's going to 3, which means our limit for this problem exists. So the limit of h is 3. If I asked you for the exact value of h at 5, h of 5, the exact value is 5. If I said, what is that value? At h of 5, it's 5. But what is the limit? Well, it's approaching 3 from both sides, so the limit is 3. Okay? Because the limits are the same from both sides. That is key. Because our limits are the same from both sides. Alright, example 6. Find the limit of f of x equals 1 over x as x approaches 0. Okay, remember, as x approaches 0. Let's plug in numbers with substitution to see what happens. Alright, we're going to go back to this method so you can see something. So, as x approaches 0. So I need to approach 0 on both sides. I'm going to approach it from the negative side, get really, really, really close. And I'm going to approach it from the positive side. It still also gets really, really small on either side of 0. So, as I'm doing this, I'm plugging this in. You can see what I would be plugging it into. Right? I'm just plugging it in to save you time. Again, I'm plugging in negative 0.5. I'm also plugging in positive 0.5. I'm plugging in negative 0.01 and positive 0.01. I'm plugging in negative 0.0001 and positive 0.0001. Okay? As I plug them in, it looks like this is going from negative 2 to negative 100 to negative 1,000. Looks like it keeps getting bigger and bigger and bigger, but negatively bigger, right? Negatively bigger. If you were to guess, it's probably going to be even larger if I got even closer, but a large negative number. Or, if you were to guess, this is probably going to negative infinity. Over here, starts off at the number 2, then it goes to the number 100, then it goes to the number 1,000. If I got even closer, 0.000001, you're probably assuming it's going to be like a million or a billion. It's getting bigger. It's getting infinitely larger, or it's going to positive infinity. From the right, it keeps getting bigger and bigger, or it's going to infinity. So from the right, it looks like it's going to infinity. From the left, it looks like it's going to negative infinity. So from the left, again, it looks like it's going to negative infinity because it's getting larger, but in the negative way. So as we look at the graph, it's easier if you look at the graph. Here's the graph of 1 over x, right? From this side, as x approaches 0, from the right, as x approaches 0, looks like it's going to infinity, way up here. Remember, we're looking for the y value. The y value is infinity, way up there. Over here, as x approaches 0, from the left, it looks like it's going the whole way down to negative infinity, right? From the right, positive infinity. From the left, negative infinity. So my question to you is, does the limit exist at 0? Does the limit exist at 0? From the left, right, it's going to negative infinity, and from the right, it's going to positive infinity. So does the limit exist? It does not exist. It's not going to the same spot. So the limit does not exist, because the limits do not go to the same place. All right. We will try to finish up the notes again when we get back.